We conjecture that if G quasi-split, there exists with a pinning. Then there's should exist a fully fitful functor. Satisfying a bunch of properties and and we means some consequences of the conjecture give you something which one can check for reality and can be proved, and actually something can be proved, although they're already quite non-trivial. But I haven't actually told you the most actually appealing aspect of this. Actually, this kind of thing, consider stack of Langlands parameter was, has a long time. People was thinking about it for a long time. The starting point was actually the following thing. If you so maybe just right here. If suppose I have a representation or G hat or whatever, it's kind of some discrete, meaning the centralizer modulo the center is finite. This is actually the most. Let's even think about the simple cases. Let's say G semi-simple, and then you consider such a Langlands parameter. Let's say even split semi-simple. You consider such a Langlands parameter, and suppose it's in some discrete in the sense that the centralizer is finite. Then in this case, actually, this point actually turns out to be a smooth point inside here. And the stack is actually has no geometry. It's pretty simple. It's just the point modulo S. This is inside here. This is like the geometrically this is simplest situation. But I mean this is but the people thought about this at the case simple at the beginning, but the point is like the category of coherent shifts on this classifying stack is exactly the representation of this finite group. So. It's a component, open closed. So this is just the representation of this finite group. So somehow, this kind of L packet or something, so on and so forth, actually encodes in the category of coherent shift if you think things as stack. This was, I guess many people has this idea. But I mean, of course, I will not elaborate this more, but let me also mention, from here you can see that this S row, usually it has a subgroup like if you consider center of G hat and consider Galois invariant this split. This is always a subgroup, okay? Finite subgroup inside here if this is a semi-simple. So and in the classical formulation for Langlands, only those coherent shift here will correspond to some like a representation in 1L packet, but only those representation of SV which are trivial here would correspond to your original G. Yeah. So if a representation like I don't know R is this group representation. Let's see. Let's even consider this lambda is QL lambda. GL. Most times it's just a abelian, but let's see. Some finite representation. This will correspond to a coherent sheaf. F is a coherent sheaf. One point here. And this one should come from representation of G. Yeah. Come from this one will actually correspond to some pi r. This is in representation. I guess this is like the classic picture, even. But then you may think, okay, from this point of view, how about the coherent sheaf, which I mean is non-trivial. As a representation, non-trivial on the center, which according to the classical theory, which this corresponding representation will come from some inner forms or some kind of extended way of inner forms of G hat. So in fact, what happens is this category, this stack, this is sort of some Freeman version, like just consider the possible modulo G hat. This is basically consider all possible homomorphisms from V group to G hat, for example, or CG, satisfying certain conditions, or maybe one co-cycle. So in particular, questions? So in particular, like the center, the gamma F, this group acts trivially on log. And therefore, actually, in some sense, this actually is a sort of a gerb over something else, and the category of coherent sheaf actually admits a decomposition. According to the character of this. Okay, and in fact, but this is, I think, has been, hopefully, I was not here Monday, Tuesday, Wednesday, but I hope this was explained. It's actually like parameterize actually this all the extended inner form of G. Okay, so then actually one could go a little bit further to, this is not the exact final story, but at least just doing representation theory, one could hope actually the representation of, if G is quite split and give a extended pure inner form, some element here, what's the notation? Denoted by beta or whatever. I don't know. Okay, so you get some group, or maybe I don't know, say some group, something like the finite general part. Then we'll faithfully embed to this. So, but let's say part. Oh, yeah, because here I use beta already. Maybe Cassie. Okay, so, depending on the normalization, how you normalize this, there should be some matching this way. So I will not elaborate too much about that, but just want to give you an example, because also this is what several people asked this. And, so the simplest example is, but also, maybe before giving the example, also I also want to mention is, we know that if, for example, the center of G is not connected, this would not cover all the inner forms of G. So that means the stack coherent shifts on this stack would not for example, G is SL2, you need to do something, actually even modify that a little bit, probably.
Can you say something about the non-semi-simple case, like GM?
See something, GM is actually even, yeah, it's okay to say, you still have this decomposition, but the pure extended pure inner form of GM are also labeled, but still. So the group are the same, all are GM, but you regard them as a different extended pure inner form. And in this case, actually, yes, as I said, the stack is basically one component times BGM. So it's literally the length. Yeah. So I just give one example is PGL2 is good. Okay, PGL2 is good. So then you have in fact, for adjoint group, like this is exactly the set of inner forms. So we don't really even don't need to lift an inner form to extended pure inner form. So in this case, so another group is just the division D cross modulo F cross. Like this is G prime. Okay, so then you might expect there's also a category representation of this group also embeds inside here. Should go to this two-dimensional thing, but in another degree. Okay, so I give you one example what it should look like. So this is sort of this kind of conjectural, but it's kind of, I mean, some part could be turned into theorem, but you can consider basically because this is it has no torus, so there's not, I mean, no representation will come from like a parabolic induction, or there's no hyperspatial thing. So the simplest thing you may consider is really just Iwahori, like a compact induction from the Iwahori, which is okay. This representation should then also go to some coherent sheaf on the stack of parameters. Where does it go to? And then the conjectures go the following. It will still be the form of a push forward of some sheaf from somewhere. Actually, now in this case, it's not a sheaf, but it's a line bundle from somewhere. But I will explain what this. Okay. So what happens is, recall when we talk about the coherent Springer sheaf, we are pushing for the sheaves from log B check, log B to log G, right? Log B check. So that's but here, what is like a Galois B-valued Galois representation? You basically in particular in the TAM case, what it is, it's just recall this log B TAM unipotent. Basically, are just the two elements. You can think about it in this way. Think about sigma tau and write the Borel, where sigma tau are still in G hat, but the sigma tau sigma inverse is tau to the Q, and the both sigma tau are contained in some Borel. Okay, like standard Borel. Let me write it in this way. I first think about they're in G hat, but then I impose they actually come from here. B hat, modular B hat. Okay, here I don't need to write B hat. But actually, you can do another thing. Actually, there's what I would call the so-called spectral Danilustic stack. It's what.
What is I? Because we're talking about the division algorithm, right?
division algebra is just yes, I is OD cross modulo OF cross or something like that. Yeah. So actually, it's just you know.
Okay, okay. I thought it was.
It's. I mean, I write it in this way, okay, but
It's finite difference.
finite,
Finite,
yeah,
just no reduction.
yeah. But I write. I mean, it could be writing more general, just but I write in this case, of course, it's quite, but it actually corresponds to some non-trivial coherent sheaf. What they are? So actually, what I would call this spectral diagnostic stack is correspond to some simple reflection S. I don't know. Let me just write this S X. It corresponds to such thing as before. But now I require tau is contained in some Borel. But I don't require sigma is inside it, but I require the conjugate of Borel by sigma by the Frobenius and sigma has relative position. I mean, are different, generically different Borels. In the case of SL2, that means there's given two Borel, they are either the same or opposite. Okay, so I want this to be like not equal. But of course, this is not a closed condition. It's kind of open. You need to sort of allow this condition degenerate somewhere. Okay. So this guy, of course, this is my pi map to G check, and actually just unipotent part. Actually, because this is unipotent, I even want this to be in the unipotent radical. Yeah. So sorry. There's a stack. I need to this, but unipotent. Let me write it in this way. Give me 1 second. Yeah. Sorry. It's okay to just use this U hat. This is a unipotent radical of the B hat. Okay. So the picture is actually what happens is I remind you there's two components. Like let's say even in characteristic 0 situation. This is Steinberg component. What happens is turns out on the unramified component tau is 1, so this is basically nothing, and here is kind of the condition sigma is not in the Borel, so it's kind of a generic condition. So the family is there's a P1 family. So this over unramified part is a P1 fibration generically. Okay. Over the Steinberg component, Borel is already determined by tau. Tau is like a regular unipotent element, so there's only one Borel component. So this is like one copy, basically. Fiber is just 1. Okay, so this is kind of a complicated geometric, like has really bad singularity, but it turns out then there's a 9 bundle who restrict to all this P1 is actually -1 curve, -1 on 9 bundle. So it turns out this push forward will be just the structure sheaf for the Steinberg component. Let's say if lambda is characteristic 0.
So what is that pi?
Pi is, I just forget, just remember this. Yeah, forget, I mean, here is, yes, because modulo, this stack thing, I just forget this and further quotient by G hat. Yeah. So that gives you an example. It turns out under this, there's supposed to also be a faithful functor, and it sends exactly this to the structure sheaf of the Steinberg component in the moduli of Galois representations. So it's of course more interesting thing is when this is FL, but the geometry, let me not.
Sorry, when does it say Steinberg component there?
Steinberg component is this component, tau is, huh? This is, the claim is this actually is isomorphic to just,
That's the Steinberg look, ST is the
Steinberg, yeah,
Steinberg component.
yeah. So, just,
How do we see that the -1 acts by -1?
yeah, there's probably some non-trivial action here, but the support is basically maybe up to twist some line boundaries on the Steinberg component. Yeah,
Could you say again what happens over the Steinberg component?
Be- because it's just 1-to-1 generically. Because once tau is non-trivial, it's a uniform regular. I mean, really, you think about it is you know, instead of consider this picture, think about the pick up a Borel, such as a unipolar radical content, and such as the Borel is, and its conjugate is generically different. So the geometry, this is 1 and this is P1, but the O, when you push forward, the O of P1 vanishes.
Sorry. So if you put this generic condition, like, shouldn't there be like a point over a Steinberg?
What's the question?
What's
The question is that like over the Steinberg, like the sigma is like 2 minus 1, right?
over the Steinberg is just a point. Fiber is a point.
Yeah, but then it does not satisfy the generic condition, right?
It does not set. Yes, but I need to, as I said, the question is, this is over the Steinberg. This when you have a Borel contain tau, it will automatically fixed by sigma. That's right. That's the reason I said you need to close it up somewhere. Yeah, it's not proper, so you need to close up somewhere. Yeah. Okay, I just give you a feeling that actually you can also describe some other where some other representation goes to some coherent sheaf. And again, it's kind of this shape is push forward of something simple from some other space to the original thing. Okay, so that's yeah. So then finally, maybe I just mention very briefly is of course this is not the end of the story. We put all this extended the inner form of G. Maybe they will all go to the category of coherent sheaves. And actually, you can take go to the different direct sum, and so you can take the direct sum of all of the representations of or extended inner forms of G go to coherent sheaves. But it's not going to be equivalent to categories. So there are more coherent sheaves on here than just come from there. So in particular, actually, this question can already be asked is you can consider, because the stack has a map to, it's quotient stack, so it has a map to BGM. So if a BG hat, so for every algebraic representation of G hat, you can pull back to get a vector bundle on it. Okay, and for example, the question is, what are these vector bundles? Does this have some representation theoretical meaning? Not it turns out those vector bundles will never land inside unless the trivial vector bundle. They will never land inside this representation theory category. But there's some, so that means you somehow need to enlarge this guy even. You need to enlarge this to get some bigger category which has a chance to be at an end to be equivalent of category of coherent sheaves. And that's, I guess, what we will hear, meaning in the second week in this work of Farga and Schultz to tell you how to define something. At least one way to define enlarge such categories. Okay, so that I guess about it's the end of the local thing. I want to talk a little bit about global aspect. So what are there any use of this coherent sheaves in the global setting? And actually, let me just state the conjectural formula and also give you some evidence. And this conjectural formula actually will also somehow relate to this Courtwait's conjecture, and maybe some as far for myself is some way to understand the Courtwait's conjecture better way. So let's consider this F is global function field. So and let's for simplicity assume G split. And I'll just ignore the difference between C groups and do L groups, so I write G hat. So so recall that Zhiwei mentioned yesterday. Oh, yeah. So yeah, before that, let me just write this global function field. So F is function field of some curve. If the Stuka, you can consider the Stuka with moduli Stukas with I legs, and then you can add some level structure, some K level structure. So maybe add some S. Or maybe N. I write, you use S or N. Okay, and this is a moduli space, and which has something to do with function field analog of Shimura varieties. At least the hope. And then these are in algebraic stack living over here. K some level. So more chunks. So then there's a geometric Satake which I cannot. I don't have time to recall. But anyway, it says the following. As Zhiwei mentioned, it produces. Actually, you need to be, like for example, in the work of Vincent Laforgue, it's really important to have this in a highly functorial way. So it produces a functor, additive functor, or in general, like functor of additive functor between abelian categories to like sheaves of perverse sheaves on this stack of Stuka. Okay. So satisfying a property. So this is what the W go to some sheaf. Maybe let me write this S. I mean, it's not the geometric Satake, but it's a consequence of like W. And it has this property that if you have a map I to J, I mean, I just think it's important to record this picture. So if I map from, let's say, surjective map to a finite set I to a finite set J, then you have an embedding from J power of G hat to I to the power of G hat. Then at the level of representations, you can restriction. And here, you can also restrict to the diagonal along this. I mean, here you have this map from here. You have the curve. level. Okay. So you have this this commutative diagram. This is what the geometric satake provide you. And then you can take the. So then it's Zhiwei in Zhiwei's lecture. Where's you're behind the, or the upper one? Oh, I see. Okay. So then one can just take what I drew as Zhiwei. Right? This you take the defined space as you first push forward this sheaf S. It's too far away. Let me just write something. Oh. I just write the give a notation. This is denoted by P. Okay. Okay. Define some sheaf here. And I take actually, I think, I mean, for my purpose, I need to take the restricted stock over the generic component of the diagonal thing. It's slightly different from what the Zhiwei notation is slightly different, where this chi is just a push forward of this sheaf provided by the geometric satake, which is a sort of an inconstructible sheaf. X here. Some input. Well, he was trying to explain there's some action of partial Frobenius, so he takes the stock over the generic point of the curve, but I want to take over the generic point of the diagonal. Okay, this is a diagonal. But because I mean, somehow he stated there's some factorization properties. They are non-canonically isomorphic. But this one will, so fact of this will be in Congshui's talk, actually, will give some important properties, like this guy is actually in Leith. So it's inductive of local systems. I mean, at least taking every cohomology sheaf, it's going to be inductive limit of local systems. And also, another important thing I want to mention is this guy admits a representation of the Wei group. Actually, the Wei form of the to the ith power act on here. You take the Galois group again, replace Z hat by Z. That's a wave form of. So it's like what right? The global setting is like this way of global, but unramified outside the finite set place first. That meets this action and also canonical the Hick action. Okay. So this is, I guess, some important, like it's will be explained in next week. It will be actually deduced from some properties in Zhu's lecture of this sheaf. Okay, and this is kind of an analog of the cohomology of Shimura varieties. It admits a action of this group and the Galois group and the Heck action. And then the conjectural formula of the cohomology, it's kind of some version, it's a version of Cartwright's conjecture as follows. So then the conjecture. We consider this, there's this map F from the stack of global Langlands parameters. Now unramify the outside N, map to the stack of local parameters. But at those places inside the V. Okay? Consider this kind of localization map. I have a global parameter. I can restrict to the local Galois representation, get the local parameter. So there's actually such a map of between algebraic stacks. So this is, let's say, over ZL. Okay, so now for each level, K is a level, only has not, outside the N, it's going to be hyperspatial level, it's only inside the N, the level. So it's, let me write it as a product of all of this. So this is some open compact. So probably Zhu will denote by X, maybe. Some open compact. And then you can, according to the local conjecture, you get some, this coherent sheaf. Here. Okay, this is a local conjecture. And now the global, the formula propose
Sorry, in the local conjecture, what are you compactly inducing? So in the local conjecture you just wrote, you have compact induction of EFN.
Yeah, of a trivial module. Yeah. Yeah. This will give you. By the way, of course, in the local conjecture, you need to, actually, to get this, you need to pick up some local Whittaker data. But actually, you can pick up some global thing which localize each local place. You get such thing. But at the end, the global shift will not depend on the choice. Not yet, not yet. This, I haven't stated the, yeah, not yet. This local conjecture is this. Then the globally, I want to see the cohomology, this HIW, as a representation. Then globally, then the conjecture is, you consider the this HIW. So because it has an action of the Heck algebra and also action of the V group. Then it's going to be conjecturally isomorphic to the global section of this coherent sheaf, some coherent sheaf on the, or incoherent or quasi-coherent sheaf on here. You take all this local sheaf you tensor them up and pull back. So let me just write this as just a kx. So, and not yet, sorry. You pull back this sheaf, and then you need to tensor with some other vector bundle on this global stack. I denote that by W tilde. This originally has nothing to do with I mean, this part has nothing to do with W or legs. But here I need to W tilde to compatible with. So what is W tilde? So recall that this global stack map to B G hat, as I'm mentioned, because it's something quotient by G hat, so map to it. And then this diagonally to B G hat to the I. I do have a representation of a G hat to the ith power W, so I can think about it just a representation of the G hat by diagonal, and then pull back. I get a vector bundle on here. That's my W tilde. Pull back, and if you need to think think it a little bit. Is that after the pullback, this guy has a canonical action of W to the I. The ith power of the wave group actually acts on this W tilde. This is you need to think about a little bit why, but it's a fact. So if let me maybe just mention this. If you have this, if you consider its fiber.
I don't think it's very clear what's written there in the title. So I think you have a W that should be without a tilde on the right. Right?
Yes. It's a representation of a W G hat I. You think about it as a coherent sheaf vector bundle here and pull back. So you get its fiber at one point. Say if I have a point on the stack, then its fiber over it. It's just it's a vector. It's a fiber over point. It's just a vector space, but it's over that point. Then it admits. Let me even think this is just the exterior product of representations of G hat I. Then this guy will be acted by Galois. Then I claim the Galois group acts on this by. I describe how it acts on the fibers. The action on the fiber is you just on ith copy. I have this. I just have this row. It's a map from Galois to G hat, and it acts on Wi and tensor. Okay. This is so then it admits action, but you can make it more formally in terms of algebra geometrically, more formal. And on the other hand, this guy will have action of the Hecke algebra. Because in the local setting, we think this is a fully faithful functor. This induced representation, its endomorphism is exactly the Hecke algebra. So this particular sheaf will have action of the Hecke algebra. So when I tensor them up, they will have this global this Hecke algebra act on it. And the claim is now this is a isomorphism. And except the only subtlety here is actually you need to not take the usual pullback of star pullback, but take some shrink pullback in the content of coherent sheaf to get the correct formula. Okay, so how does this looks a little bit abstract at the beginning? So let me just give you a concrete example what will happen in a concrete situation. So let me.
So just in case you don't have level structures, so n is empty.
Yes.
Then we cover the Cauchy's conjecture that Xinwen described yesterday in the
it will. So first of all, let me see the following thing. If n is empty, okay. So, because I mean, when I define the stack, I always make it non-empty at the beginning. But it's okay. What I need to put is a coherent shift. The coherent shift, anyways, just support on the everywhere unramified locus. So it turns out, first of all, this guy, the pullback. Okay, everywhere unramified. It's just the canonical shift of this. So in this everywhere unramified situation, I should mention this was also conjectured by the 6th author, like Arikin. It's hard to remember. Arikin, Getzgrey, Kashtan, Rosenblum, Raskin, Warshawski, and some. Okay, there's some 6 authors. They also have at least in everywhere unramified situation, they have such exactly exactly this kind of conjecture. But in general, it involves this coherent shift on the local stack, and you take the shrink pullback. And then I want to talk about even in the everywhere unramified situation. See, in general, this geometry of this stack is complicated. So I will just localize this at some nice point, those isolated smooth point, to see what happens. Okay? So suppose, for simplicity, I will assume this G hat is G is semi-simple. Even, and what I want to say. Okay. So actually, no need to see semi-simple. So definition, a Langlands parameter. Maybe just writing it this way, is called elliptic if it's sort of isolated smooth point in the moduli space. But actually it's equivalent to this the centralizer modulo this group. It's finite. Okay? I think globally people use locally people use discrete. Yeah. Maybe globally is okay. Which words do you use? Discrete? Okay. Yeah, discrete also makes sense because it's discrete in the moduli space. Elliptic dash discrete. So G. I mean, sorry. Yeah. This guy. Just V group. Sorry, but this is a point inside here. That's what I was trying to say. ZG hat, modular center. So just as in the local system, I mentioned that this actually is the stack looks like this. This is open and closed inside here. Okay, so let's just localize this conjecture in this particular setting. What does this say? I mean, I guess Kottwitz originally the conjecture is also, I guess it's just for discrete part. Maybe Arthur also later on extended to the whole cohomology. No, maybe I was trying to. Anyway, so let's localize here. Let's localize here. What does this mean? That means this cohomology now, of course, this action of now after maybe next week you will see this this cohomology really has the action of the so-called excursion algebra can be localized on the moduli of coarse moduli space of Langlands parameters. But in the case of elliptic, in this particular parameter, I can just take a direct sum. So that's something like this. But now the stack is just a point more something. Let me just write this sheaf as A, global. K, that means global. Sorry. So you can think about then this. You can now rewrite this is as follows. Just a tensor with W, taking S. Global section is just taking the invariance. But of course, taking invariance in, yeah. I think this is only well behaved when lambda, let's say, is QL bar. Other this notion, I mean, let's also for simplicity consider QL bar. And if you so. This is coherent sheaf on the stack, so this is going to be a sheaf equipped with the action of all this as finite group, and this finite group, because it's a subgroup of G hat, so it also acts on W. Okay, SV. So SV requires it's something it's a subgroup in G hat, so it also acts on W. So then you take the invariance. That's the formula, and if you write it out, because you are mapping point to points like this upper streak of a tensor then for x in n tensor this W taking the invariance. So that's the formula for the cohomology, and yeah, time is almost over. So maybe let me state the theorem and presumably leave to Q&A to see how this is more somehow related to more classical version of a Courtwait's conjecture. So maybe it's so I guess the case is the first one is the starting point is the original, in particular case, proved by Vincent Laforgue and myself, and then slight generalization by myself, and then there's a 6 authors paper doing, but this is everywhere on ramified situation. But this is but the derived version. But let me just state the abelian version is there exists a coherent sheaf I for each I for every I actually quasi-coherent sheaf. Or maybe, yeah, on here. Such that the cohomology, this guy, is really of that form. Maybe taking the ice cohomology. It's really taking the ice cohomology. Oh, sorry, it's taking the global section of this AI tensor W tilde. Yeah, by the way, I should mention, because this is an affine scheme modulo reductive group in characteristic 0, this taking global section is the exact functor. So yeah, and the important thing is lambda is QL bar. So in this case, the cohomology can really be expressed as some certain global section of certain coherent sheaf on the stack of global Langlands parameters. Okay, so but of course all this work could could not show this coherent sheaf exactly of this form at the moment. Yeah, so let me, I should mention, like this, with Laforgue, actually we first prove this just over this discrete part, this elliptic part, which formula is much simpler like this, but then it can be extended to the whole stack and even derivedly by this sixth author.
So the point here is that you can vary the W, right?
You can vary the W. For every I, every W. Just there exists a quasi-coherent for every I. And such that for every W, every I, every W, the cohomology looks really like this.
So the question is, you don't know that it's AI factorized surface,
We don't know.
but you do know that it does solve the discrete problem.
Discrete, it should be something like that, but
Okay,
it's
still a question.
it's still a question. Yeah, the factorization is a big thing, but let me just give you an application of even just this existence of the coherent sheaf. I mean, this factorization will also let in this how multiplicity decompose locally. So, some application, because I think I have like 4 minutes or so, 4 to 5 minutes. So this actually already have pretty non-trivial application in the case of GeoN. This was application. It's just GeoN, global function, which is not, I didn't assume semi-simplicity, so that's probably fine. Okay, so then you just localize this at the, so then in this case, elliptic or discrete of rho is equivalent to irreducibility. Irreducible. Okay, irreducibility. Because the centralizer of a representation in GeoN is always connected. If the modulo center is finite, that means it's just a GM. The center is just a GM. Like so, it's the same as irreducible. So, and in this case, we know the corresponding automorphic form is actually the automorphic form actually is correspond to cuspid. If you some pi correspond to rho, then representation must be cuspidal in this case. Yeah. By the way, I should actually with Laforgue we prove actually slightly stronger, not just this formula. It's actually what we prove is this tensor product is factored through the action of this. I mean, each individual thing may not be. Actually, from Zhuwei's talk, this guy, when Shiduka exists, it's really, when you restrict to the diagonal, W must be a representation of G hat modulo, already modulo this centralizer. So in fact, this group acts on here, and we prove this group acts on here. And what happens is the whole thing is act on, so the quotient act on. This is slightly stronger than the statement in general. But in this case, okay, so that means in the case of GeoN, this becomes trivial. So that means HIW is just some sheaf A, K tensor with this W as a as a representation. I already explained to you. W is basically you think about the rho. You think about the take a ith exterior power of rho, and then compose with W. But what does this formula tells us is if you just let I to be empty, so W is a trivial representation. Okay, By the way, this guy is gonna be a Hick module. This guy is gonna be a Hick module. It's a module over the Hick module, and we know this H empty one row is just the pi row, pi w. It's like the strong multiplicity one or whatever. Okay, so what we recover from just this formula is WHI. In any cohomology of moduli Shituka with any legs, the cohomology really looks like this, just as expected. By the way, after normalization in degree 0, but in degree I, when the leg is empty, there's no cohomology in degree I, it's a discrete set. That means actually the Caspita automorphic representation does not appear in other place. It's empty. The Caspita pi does not appear in other cohomology in other degree. So I guess even just with cohomology with two legs, Laurent Laforgue, when he proved this global Langlands for GON, only proved some results weaker than this kind of statement. But now it's true. Just okay, I stop here.
A very short question. Which of the papers do you believe is KGKR? I think they have two, right?
Huh?
Like just which paper is it?
I actually I don't know. There's series of papers. So, somewhere, yeah, they probably, yeah, maybe they proposed this as a conjecture in their first non-paper and prove it in some subsequent papers or something like that. But again, just the existence of A, nobody could really identify what is A. Like in every unramified case, one would expect the A is just a dual Langlands sheaf, but that's far from being solved.
I try to understand for your identity for the HIW localized rho, and then in the right hand side, the AK and WK doesn't depend on rho, and all these involve rho is just X rho. Why is it?
Yeah, this is a sheaf on the stack, so basically I take its fiber over. Okay, I could say it's I maybe I also restrict this to row. Okay, yeah. This is.
I think I have a naive question, which is there a non-conjectural way of describing AKX?
I give you some examples like the case of Iwahori level, or maybe for quaternion algebras, in principle for parahoric level, there's supposed to be some way to describe it. When you level go maybe pro-parahoric, like pro-p parahoric, like those probably there's some way to describe it. When you go further, I think something needed. Like for GON, for full level, I also gave us some conjecture this morning, full level.
Okay, so let's thank Xinwen for a wonderful series of lectures.